On. Welcome all of you in MH Math classes. Today I'll discuss uh, regular graph and complete graph and what are the examples of regular graph and complete graph in graph theory. Okay, so let's start the topic. What is regular graph? Actually, if I already discussed in previous video, what is the degree of a vertex? Okay, so if actually degree of a vertex is the number of edges connected to the vertex or incident to the vertex is called the um, degree of that vertex. Okay, so what is regular graph? If degree of each vertex, if degree of each vertex of a graph be same or equal, degree of each vertex of a graph be same or equal, then that graph is called regular graph. Suppose degree of each vertex be r. Okay, if r be the degree of each vertex of a graph, then graph is called r regular graph. Then graph is called r regular graph. Okay, r regular graph. So what are the examples of this graph, regular graph? See, this is one regular graph because this is one regular graph. This vertex 1, this vertex 1, and this is 2. Here number of vertex is 2 and number of edges only 1. So two vertices are same degree because one edges are adjacent each vertex. Okay, each vertex are incident to only one edge. So number of degree of vertex 1 is 1 and degree of vertex 2 is 1. Both the vertex have same degree. That's why this graph is called one regular graph. One regular. One regular. Okay. Now, what is two regular graph? All the cyclic graphs are two regular graph. Okay. All the cyclic graph. This is C4 actually. This graph is C4. Okay. देखिए सी the degree of vertex 1 is 2, vertex 2 is 2, vertex 4 is 2, vertex 3 is 2. All the vertices have same degree which is 2. Okay, that's why this graph is called two regular graph. Okay, all the cyclic graphs have all the cyclic graphs are two regular. Suppose this is a graph, this is C3. Okay, three vertices here, 1, 2 and 3. This is C3 or you can say this is K3, complete graph. We'll discuss complete graph later. Okay, so this is C3 and this is also a two regular graph. This is also a two regular graph, or you can say cyclic graph with 5 vertices. This is also a cyclic graph where vertices are 5. 5 vertices here and all the vertex have same degree which is 2. Okay, two each edge are connected with two edges. Okay, that's why each vertex has degree 2. Okay, so this is also a two regular graph. These two are two regular. Okay, now what is three regular graph? If here see This is three regular graph. Okay, because three edges are connected with each vertices. Okay, that's why degree of each vertex in this graph is 3. That's why this is 3 regular graph. And see here, this is 4 regular graph. Okay, 5 vertices here, sorry, 5 vertices here. Okay, each vertex have incident to, each vertices is incident to 4 edges. That's why each vertex have degree 4. Okay, degrees equal degrees of each vertex in this graph. Okay, this is k4 actually. This is k4. Sorry, this is 1, 2, 3. This is k5. 5 vertices now, and complete graph with 5 vertices. And this is k4. Complete graph with 4 vertices. Okay, so this is regular graph. Or if similarly, if we draw a vertex with all the k5 or k6 are regular, all the complete graph are regular graph actually. Okay, all the complete graph be regular graph, because each vertices are incident to or adjacent to each other. Okay, and maximum number of possible edges are connected. Maximum number of possible edges there in complete graph. That's why it's called complete. Okay, so complete graph are regular graph. Every complete graph are regular graph. Okay, every complete graph be regular. Okay, so the I hope you understand the regular graph concept of regular graph. Now we will discuss. Now we discuss complete graph. Okay, what is complete graph? A simple graph with maximum number of edges. Okay, a simple graph. See, simple graph means we already discussed in the previous video. What is simple graph? No loops and no parallel edges. Okay, no loops. That means if a vertex, this is a vertex, so no loop. This is a loop. Okay, if this is a graph and this is a loop. Okay, if this is a vertex and this is a loop. Okay, so simple graph means no loops and no parallel edges, and this is parallel edges. Okay, suppose this is a two vertices, 1 2. Okay, this not this. Suppose this two are vertices and this is parallel edges. Okay, so a simple graph means a graph without loops, self loop and parallel edges is called a simple graph. Okay, so now we define complete graph. Now we define complete graph. See, what is the definition? A simple graph, a simple graph with maximum number of edges, maximum number of edges is called complete graph. It's called complete graph. Okay, clearly a complete graph on n vertices. Suppose uh, G be a graph, G be a graph with n vertices. Okay, G be a graph with n vertices, then maximum number of edges here nc2. That means n into n minus 1 by 2. This is also a formula. Okay, in a complete graph, if G have n vertices, then a complete graph G with n vertices has nc2 edges. Okay, nc2 edges. Okay, n into n minus 1 by 2. And this complete graph is denoted by kn. Okay, n equal to 1 2 3 4 like that. Okay, so this is denoted by kn. Okay, this is denoted by kn, right? And also, so see, what is the examples of complete graph? This is k2. Okay, two vertices here. Okay, two vertices, and this is complete. Okay, no other vertices. If we join any other edges between these two vertices, then this graph is not simple, because if we draw from here to here, then this is a parallel edges. So this graph is not simple. And what is the definition of complete graph? A simple graph. So maximum number of possible edges here, only one. Okay, and if we put here a number of vertices here, what? 2. Number of vertices here 2. So what will be the edges? 2c2. So 2c2 means 1. So number of edges here 1. This is a complete graph with 2 vertices denoted by k2. Now k3. This is a k3. Also this is a cyclic graph c3. Okay, we already discussed. This is a k3. Okay, number of vertices here 3, and these are the maximum possible number of edges. Possible number of edges here 3. Okay, this is k3. This is k4. Okay, here number of vertices here 1 2 3 4, and what are the edges here? See, nc2, that means 4c2 equal to 4 into 4 minus 1, that means 5 by 2. So here 2, that means uh, sorry, 4 minus 1 3 na. So 6 edges here. Okay, 6 edges here. You can see 1 2 3 4 5 and 6 edges in this graph k4. So k4 is a complete graph. Maximum possible number of edges here 6. Now this is k5. This is k5. Okay, 5 vertices, and what? uh, 5 vertices here 1 2 3 4 and 5. What are the number of edges? Maximum number of edges here 5c2, that means 5 into 4 by 2. Okay, that means 10. You can count all the edges. 10 edges in this graph. In k5 there are maximum number of edges in k5 is 10. Okay, so this is a complete graph with 5 vertices, which is denoted by k5. This is k6. This is k7. Okay, so these are the complete graph. Okay, now if I ask an n comma m graph, g equal to, suppose g equal to n be the number of vertices, m be the number of edges. Okay, be a graph with n vertices and m edges. Okay, so this is equal to 5 comma sorry, we can erase this. Okay, now this is equal to number of edges, suppose 5, number of vertices, and number of edges 8. Number of edges 8. N equal to 5 and m equal to 8. Okay, then is it 3 regular graph? You can see uh, here is this graph exist or not? Is this graph exist or not? How we will show this? How will check? Okay, this graph exist or not? 5 vertices and 8 edges. Okay, we can use uh, by handshaking lemma. We will say that this graph exists or not. So every simple graph or every graph satisfy the handshaking lemma. Okay, handshaking lemma means what is the statement of handshaking lemma? Total degrees equal to twice the number of edges. Okay, so vertices are known here, but degree I don't know. Okay, we don't know the degrees of each vertex. Okay, only vertex and edges here given. So sum of degrees is equal to twice the number of edges. Okay, the number of edges means here number of edges 8, so 16. Okay, so uh, number of edges 16. That means this is uh, total number of degrees here. Total number of degrees here 16. Okay, in 5 vertices. Okay, but uh, uh, 5 number of vertices 5. Okay, graph exists, but graph exists. Okay, total number of degrees 16, number of vertices 5, total number of edges 8. Okay, and total number of degrees of each vertices, total number of degrees. Okay, all the vertices degrees be 16. Now tell me, this graph exists, but this is not three regular graph. If I ask, is this three regular graph or three regular graph with five vertices is possible? No, three regular graph with 5 vertices is not possible. Okay, because three regular graph with 5 vertices is not possible to draw. Okay, because total number see, three regular means three regular means three regular means number of each vertex, degree of each vertex is 3, and so 3 into 5, 3 into 5 means 15. And by handshaking lemma, by handshaking lemma, 15 equal to twice the number of edges. Number of edges here 8, and number of edges here 8. So 2 into 16, 2 into 8, which is equal to 16. So 15 not equal to 16. Handshaking lemma not hold. So three regular graph with 5 vertices is not possible. Okay, so this graph exists, but this is not three regular. Okay, now this is the can you say this is complete? Is this complete graph? Number of vertices here 5. Okay, number of vertices here 5, but maximum number of possible edges in K5 what? N into n minus 1 by 2, that means 5 into 4 by 2, that means 10. Okay, so but here 10 edges are not, 10 edges are not here, 10 edges not belongs to in this graph. Okay, or in K5 or in Kn, actually complete in complete graph, actually in complete graph, each vertex, each vertices are adjacent to each other. Okay, but you can see here each vertex, 1 is not adjacent to 3. Also 5 is not adjacent to 3. So this is not K5. Okay, this is not K5 or this is not complete graph. Every complete graph, is, in every complete graph, every vertices are adjacent to each other. Okay, maximum number of possible edges on that graph, then that graph is called complete graph. Okay, now uh, on question, sorry, uh, what is the number of edges on three regular graph with 6 vertices? Can you say what is the number of edges? What is the number of edges on three regular graph with 6 vertices? With 6 vertices. Okay, so we can directly say this: three regular graph with 6 vertices means in R regular graph with n vertices have R into n by 2. Okay, R into n by 2 number of edges. Three regular graph, that means by handshaking lemma we will say this. Handshaking lemma says total number of degrees. So here 3 regular means each vertex have 3 degree. Okay, so here number of vertex 6. Okay, 6 vertices have equal degrees, which is 3. 6 vertices, total number of vertex 6, and each vertex have degree 6, 3 equal. That's why this is called three regular graph. So 6 into 3 equal to the twice the number of edges. So number of edges is equal to 6 into 3 by 2. That means 9. Okay, total number of edges here 9. So can you draw this graph? See, total number of vertices 6. Okay, 1, 2, 3, 4, 5 and 6. Total number of vertices 6. Okay, now 9 edges. Okay, so here also you can see E1, E2, E3, E4, E6, E5 and E6. That means 6 edges already here. Now 3 edges will connect each vertex between two vertices. Here this edge and this edge. So this is three regular graph with how much vertices? How much edges? 9. Here this is a graph with 6 vertices and 9 edges. Okay, like that you can solve the graph or this type of question related to uh, complete graph or regular graph. Okay, so I hope you all are understand what is regular graph and complete graph. Okay, if you have any doubt or question, then please comment in the comment section. Okay, so thank you for watching, and please like, share and please subscribe my channel. Thank you.